This episode is sponsored by Squarespace. Welcome back. We are in Wolverhampton at W.H.Tildesley, which is a drop forging company that has been running for 149 years straight. They have made parts for both world wars on this very site, and the drop forging that we are going to see is ridiculous. We're going to learn about it too. What you see mostly on our channel is open die forging, either with a hand hammer or with a power hammer. Well, drop forging is a closed die operation. You remember when we went to do the factory tour at DMM? We saw a snippet of that. Here, they are specialists in one-off jobs, crazy materials like titanium and nickel alloys, and they've got some wild simulation software to be able to design the dies that they then make in-house. And it starts like this, a giant block of steel where they've sawn out the beginnings of a dovetail. The block then comes to this mill where the dovetails are cut in. Dave, thank you very much for having us. Could you tell us a little bit about what happens when the customer says, hey, we need this part made, and you need to make a plan for how those dies are going to be made? What does that look like?
Well, the start of the process is the customer sends us an engineering drawing. We then interpret that into a CAD/CAM drawing. We plug the information, the parameters into the simulation software, and that gives us a first idea on an estimated method of manufacture and which hammer or which machine we're going to manufacture on. And it suggests to us how many blows, what it's going to look like, the flow of the material. It's a best estimate at the time we start. We then forge based on that estimate, and then we can feed back into the software to get an even more finite cut of how to manufacture. There is no database out there that says, right, for titanium or for carbon steel, this is the temperature, the exact temperature best for forging that material.
Under this particular power hammer?
Under this particular power hammer.
Got it.
So we have to create our own database of parts versus temperature versus hammer versus shape. But we're creating our own Tildesley database of metallurgy, and that's what we excel in here, is metallurgy and knowledge of how a super duplex is going to behave versus carbon steel versus titanium. The biggest factor is the knowledge of the guys. It's a horrible expression, but they are metal whisperers. They understand the metal. They can feel it.
There's a really interesting kind of dynamic between feel and technology. Yes. You've got all the technology to make you a lovely simulation, but at the end of the day, the guys on the shop floor say, no, this one particular part needs 8 hits instead of 7 hits.
We've got a guy on our biggest hammer whose father worked here and his grandfather worked here. And he's only ever worked here. And his wife works here.
So you talk about institutional knowledge, you talk about, you know, knowledge, feel, experience. It's generational here.
Yes.
That's wild. So you've got your simulations done, you need to make the dies, you make them in-house in this machine shop right here. I want to see some dies. Now, before we talk about the space that is removed by the milling machine for the material to go into, why don't we talk about the space where your business lives on the internet? Your Squarespace website, who's the sponsor of this episode. It's an all-in-one platform, and their mission is to empower absolutely anybody to have a beautiful website that they can create, maintain, and update themselves, giving you, the artist, small business owner, or even large business owner, the ability to serve their clients no matter how it might be. You can sell unlimited physical or digital products with Squarespace. You can use Squarespace integrations to then interact with third-party drop shipping, merchandise printing, or other fulfillment services. And if you sell your time, you can book it out using Squarespace scheduling. It intersects with your other existing calendars to make sure you never have a double booking, and you'll never have to worry about plugins, patches, or upgrades ever, because it is a truly all-in-one platform. From purchasing your domain to running your email marketing campaigns, you can do it all. And if you go to squarespace.com/forge, you'll get a free trial to see just how good it is, and using code FORGE at checkout will get you 10% off your first purchase. That includes the purchase of your domain. Check them out. Let's get back to the video.
The simulation will create a cutter path, which is effectively a direction for this machine to cut the metal to create the die.
And that transforms it from looking like this to looking like that. They'll typically have multiple impressions in one die block. This is a molder, so it's more of a rough form. And then over here, this is a finisher. So this one is much more detailed, and it has the lettering that needs to be stamped in as well. So since you guys deal with crazy alloys, sometimes these dies don't last very long.
Sometimes they'll last 100 parts, sometimes 800 parts. But because the material's so hard and the hammers are so heavy, more often we'll get breakdown in the very edges of the die. Once these surfaces here break down, we have to recut the die.
And so it could be 100 components, and then you've got to completely mill off all of this and start again. That is incredible expense. Are you able to say, like, roughly how expensive a set of die blocks is to make?
It can vary from a few £1,000s to many thousands of pounds. It's very hard to identify when a die is about to collapse. That's where I'm very reliant on the experience I've got, because I've got stampers who've been stamping for 30, 40 years. They can tell by the feel of the material that the die is about to go.
Off the mill, it's not yet ready to go into the drop hammer. It needs final hand finishing. Hope you don't mind if we come and see your work and what you're doing. 45 years. Incredible. Look at this amazing workbench that they have with this spinning Lazy Susan on there to be able to position the die as it's being worked. Got it, so you've got to make sure there's no sharp corners in here, and that's going to be your role.
All the milling marks out.
Do you put the lettering in by hand?
Some of them.
So kind of synopsize for the camera, over here with pneumatic die grinders and angle grinders, it gets the final polish put on, and what we've just learned is that if there isn't a good enough polish, the part can get stuck, and then that's not practical, is it? For all of the different jobs that they have 10,000 dies. This is just one of their die storage areas, filled with hundreds of tons of precisely machined steel. Oh, Jamie, we're about to see a big old smile on my face. Those dies then get taken through to a room that might just be the coolest room I've ever been to. The drop forging room. Have a look at these beautiful machines. Okay, so we are here with Ash.
Right, mate.
Lovely to meet you.
And you.
So what are you making today?
I'm going to make some fireman's axes.
Fireman's axes, brilliant! And you've got some beautiful tools to play with. This massy clear space power hammer.
Yeah, 500 weights.
It is just beautiful. And then how big's your drop hammer?
1.6 ton. I lift it up, get it to have it on the pedal, see how it works.
Okay.
And then we'll start forging.
So you've got the moulding on the left, finishing on the right. Oh, I do love a clear space. It's been a while. So are you wanting, you just like floor it?
Full heavy blow, so
You just floor it to the bottom?
yeah, straight down.
This is the furnace right here, and I thought these bars are going to be way too hot to hold. Check it out. They've got an air blast blowing a curtain of air up. Look at that. Right next to that big furnace, and the metal is cold enough to touch. Okay, here we go. First fireman's hatchet. Oh, that power hammer is beautiful. Okay, into the first forming die. What? Look how hot it gets. Wow, that's ridiculous. And then into clipping and trimming the bar. Whoa, that is nuts.
Turn over. Front and again.
Oh my goodness. I made that one. Right, here we go again. Into the first set of dies. There. Woo! Oh my goodness! I'm having such a good time. These machines are so cool, and wow, I can't believe it. I can't believe I've made any functional parts. You're a great teacher. Next up, we are going to drop forge some titanium. This is more of the awesome, unique stuff they do. Drop forge titanium here in Great Britain. That is a 3.2-ton drop forging hammer. So that's twice as heavy as the 1.6 ton that I was using earlier. And again, the scale of the clipping press. All all of this, it's just enormous. So here is some titanium billets ready to be drop forged into these con rods. So when we were looking at the simulation software earlier, we found that it is not just a one and done operation. It is very much an iterative process. So the software might have said, hey, start with this bar, but in testing, they found that in fact, they needed to pre-form it, pre-machine it, and we're gonna see just why that is as we go through all these different steps. The titanium here has a ceramic coating on it to extend the amount of duration they can forge it. That's why it looks white. The titanium they're making these con rods from is recycled titanium, and what's wild is it is sintered. They are forging sintered recycled titanium. So the furnace rotates, and he's got a foot pedal there on the ground. The pedal doesn't just spin it. As you press one pedal or the other, it moves the furnace from one slot to the next. So you can go, oh, I want my billet here, and then 15 degrees around in a circle, I want another billet. You press the treadle to move the furnace round to where your next piece is. When you've got to change dies, this is the hammer for driving the keys. They hook it on a chain up to here, and it's a swing hammer for driving keys. How cool? Oh, they're the dies for the titanium preheated. So it just didn't go well. That titanium didn't flow.
Nowhere near filled round here.
Yeah.
You'll probably find you've got a crack running down there.
What we saw is a billet shape that wasn't quite right, was a little bit better, but still not quite right. And this is what they've had to come up with to actually make the part. It's this turned round section, and that is a much nicer freeform.
Again.
Would you look at that? We did it. That was stressful. This part filled the die properly, and that's because of the preform that they had to develop. They had to develop the perfect preform, and that takes not only the computers, but also the skill and experience of these talented people here to come up with a preform that works, even for an amateur like me who steps under the machine for the first time. In this part of the factory, we have one of the largest drop hammers here. Spanning 3114. This is a 4-ton drop hammer. Over there is an even larger Massey Clearspace power hammer behind an enormous clipping press. Check this out. That's a swing hammer. Oh yes. They have a gantry system that is in an oval, and it goes the whole way around so that they can hoist material with that chain on all of the equipment. And here, out of this 85mm, 3.5-inch round bar, they're going to be making a chain rod end. This is a 1000 weight Massey Clearspace power hammer. The Massey Clearspace is one of the most iconic power hammers in the world. Best control, it's just special, and they've got so many of them. 1000 weight. That is a ram that is over 1,000 pounds. Half a ton of falling weight. I love it. Come have a look at this. You thought that we've looked at the biggest Massey Clearspace power hammer. We haven't. We're going power hammer hunting. Look at this. That is a 1,500 weight Massey Clearspace power hammer. This is the largest Massey Clearspace power hammer I've seen in my life. It's beautiful. Oh, that is lovely. Woo! Beautiful machine. Holy crap, here we go. Oh yeah, that's some steel. So they just knocked the scale off on that first hit. Then necking it down. That's a big forging. That's a big bloody forging. Woo! That's a lot of metal move.
That's a big bit of steel. Let's have a look at how this 1000 weight Massey is set up. First of all, they got themselves a nice little table area right here for resting tongs and putting the workpiece there so it doesn't drop down past the anvil. All of their equipment has one of these big blowers blowing air through pipes. That way they can get an airstream down onto the dies to blow off the scale. You can imagine if you had scale on your workpiece and then took that scaly workpiece to the drop hammer, you're just pushing that scale right back into it. You're going to mess up the dies and mess up the workpiece. So having as little scale as possible is really important to these guys. And there's the same thing over here. Big blower through this massive bit of pipe work, blowing more air onto the dies to force away the scale. It also makes it safer for the operators because then, as you hit, when the lubricant and the scale wants to fly out, you blow it away from the operator's face. The furnace, just like the furnace for the titanium, spins constantly so that it gets an even heat. Got 3 pedals on the bottom. Middle one does the doors. They are some nice forge doors, dare I say. Look at that. Thrilling. Just thrilling. For the clipping. Was fun. Thank you. Thank you for letting me do this. I feel like a kid in a candy shop, you know? Thank you very much. Thank you very much. This is serious work, serious skill, and incredible machinery. Folks, thank you so much for joining us here at W.H.Tildesley and learning about drop forging in Great Britain at this phenomenal specialist manufacturer. Check out their website down below. Thank you so much for watching.